Hi, so today we are going to be simplifying radical binomial expression. That means that there are two things that we can simplify right here. So, for example, I'm going to start using the addition one. So in this case, we have to check two things before we start adding. The first one is that we have the same index. And the second, we have the same number inside of the same radical. So in this case, those radicals are exactly the same, the square root of 6 and the square root of 6. So that means that I can add those two. So this is just 12 square root of 6. As you can see, I'm not adding inside. I'm just adding the numbers outside, because that means that I have 10 square root of 6. And then I have 2 square root of 6. So when I add them all together, I have 12 square root of 6. So number 2, as you can see, even though we have the same number inside, we do not have the same index. So that means that we cannot simplify. Simplify, or we cannot add. And that's it. We don't have to. We cannot do anything else on number 2. And number 3, again, I have a square root on both of them. I have the same number inside. So that means that I just can subtract those numbers. 8 minus 5 is 3, square root of 3x. And that's it. We don't have to do anything else on that exercise right there. Okay, let's see number 4, right? So number 4, we don't have the same radical. We don't have the same number inside. But before we decide that, if we cannot do anything else, we have to check if we can simplify. And 12 and 75 are two numbers that I can simplify, right? Because 12 I can write as 4 times 3 minus 75 I can write as 25 times 3, right? So the square root of 4 is 2. Square root of 3, right? Because 3 does not have a perfect square root. The square root of 25 is 5, square root of 3. And as you can see now, I can simplify. I can subtract those two because the square roots are exactly the same. So this at the end is negative 3, square root of 3. Okay. And number 5, again, I'm going to start by simplifying the 12. We already did it on the last exercise. So 5 square root of 3 plus 2 square root of 3. Again, the square root of 12 is the same as the square root of 4 times 3. The square root of 4 is 2. And I have the square root of 3 left inside of that exponent, of that radical, sorry. So now I'm just adding 5 plus 2 is 7 square root of 3. That's it. On number 6, I do have the same index, but I don't have the same radical, and I cannot simplify any of those two radicals to change it so I have the same. So that means that I cannot add. And that's it on that exercise. Okay. So number 7. Again, I'm going to check if I can simplify all those numbers. As you can see, they don't have the same radical, but maybe we can simplify. Let's see. So the square root of 28 is 4 times 7. The square root of 175 is 25 times 7. And the square root of 63 is 9 times 7. Okay. Right now you can see that all of them have a 7 inside of them. So maybe that means that we at the end are going to be able to add them as subtracting, right? So the square root of 4 is 2, and I have left inside the 7, minus the square root of 25 is 5. I have inside the square root of 7, plus 3 square root of 7. So now I just have 2 minus 5 equals negative 3 square root of 7, plus 3 square root of 7. And when I subtract negative 3 square root of 7 plus 3 square root of 7, that's 0. And 0 is a possible solution. So we can see we cancel out the square root of 7, because when we multiply the square root of 7 times 0, it's just 0. Okay. Now I'm going to multiply binomial expressions. So you can see I have two numbers, two terms on each one, so that's why it's a binomial expression. And I have to FOIL, or if you prefer using the box method, that's up to you. So that means that I'm multiplying 5 times 2. That's 10. Now I'm going to multiply 5 times the square root of 5. So that's plus 5 square root of 5, because I cannot multiply something that is inside of the radical times something that is outside of the radical. Then I'm going to multiply 3 square root of 2 times 2 square root of 2. So that is plus 6 square root of 2. As you can see, I'm multiplying just outside. And at the end, I'm multiplying the 3 square root of 2 times the square root of 5. So that means that this is 3 square root of 10. And now we're going to check if we can simplify anything in there. I cannot simplify, I cannot add, we don't have any like terms. And we cannot simplify any square root. So that means that we're done with that exercise. That's my solution. See number 9. Again, I'm going to FOIL. So first, 5 times 7, 35. Then we're going to multiply the outers. So 5 times the 4 square root of 5 is 20 square root of 5. Now I'm multiplying the inners. So that is plus 14 square root of 5. And last, I'm going to multiply the last, right? So that is 8 square root of 5 times 5 is 25. Now I'm going to simplify. Why? Because I have, first of all, I have like terms. So this is 35 plus 35 square root of 5. And last, that I can also simplify that square root of 5. So this is 8 times 5. So I have 35 plus 35 square root of 5 plus 40. And I'm seeing that I have a mistake, small mistake right here. This should be a 14 instead of a 15, right? Because I'm multiplying there 2 times 7. So this is 14. So now this is 34. And this down here should be 34 also. 34. And now I have 75 plus 34, the square root of 5. And that's it. As you can see, I'm adding like terms right here. Those two like terms to give me 35. Let's see these two last exercise. Okay. So I'm multiplying again. FOIL method. So 4 times 4 is 16. 4 times 4 is 16. 4 times negative square root of 3 is 4 square root of 3. Now, square root of 3 times 4 is positive 4 square root of 3. And positive square root of 3 times negative square root of 3 is the square root of 9. So that means that I have 16. I'm going to cancel those two, minus 3. Right? And this is the same as 13. Okay. And the last one, or not the last one because I want to show one more, okay, or two more. So 5 times 5 is 25. 5 times 3, square root of 2 is negative 15, and square root of 2. Now the square root of 3 square root of 2 times 5 is plus 15 square root of 2. And then the last one is 3 square root of 2 times negative 3 square root of 2 is 9 square root of 4. So this one, those two cancel. 25 minus 9 times 2 equals 25 minus 18, and that is 7. As you can see on those two exercises, I have conjugate pairs, right? 4 plus the square root of 3 times 4 minus the square root of 3. And I have 5 plus 3 square root of 2 times 5 minus 3 square root of 2. And what is happening here is that we cancel out that radical. We are going to see that when we are rationalizing a denominator with addition or subtraction. We're going to see that later on. So the last two exercises that I want to go over are what happens if I'm raising a binomial with square root, let's say 4 square root of 2 square. Remember that this square right here means that I'm multiplying that 4 plus the square root of 2 times itself. So that means that I have to FOIL. So I have 4 times 4 is 16, right? 4 times the square root of 2 plus 4. Now I have plus 4 square root of 2. And then the square root of 2 times the square root of 2 is the square root of 4. Means that I have 16 plus 8 square root of 2 plus the square root of 4 is 2. I have 18 plus 8 square root of 2. But again, that 2 outside here, we are FOILing this binomial. We have multiplying times itself. We are not just raising each number to the square. And the last one that I want to see is something similar to that one. Minus, let's say 2 square root of 5 square. So again, this is 3 minus 2 square root of 5 times 3 minus 2 square root of 5. So it's 9 minus 6 square root of 5 minus 6 square root of 5 plus 4 square root of 25. Okay, so this is 9 minus 12 square root of 5 plus 4 times 5. So 9 minus 12 square root of 5 plus 20. So this is 29 minus 12 square root of